So on page 2 of your Unit 5 class notes, again, you filled out the page 1, which is a review of inverse functions. The key thing before we talk about the inverse sine function is the last part where we talked about how in order for your inverse to be a function, you have to have your function pass not only the vertical line test, but the horizontal line test. So before we talk about the inverse sine, let's go back and let's just review what the graph of sine of x looks like, going back to Unit 2. Remember the parent function sine of x? Start the baseline. Our max and mins were negative 1 to 1. Then we went to the maximum, minimum, baseline, maximum. So that's what the graph of sine of x looks like from 0 to 2 pi. I'm also going to take a look at the graph from negative 2 pi to 0, baseline, max, baseline, minimum, baseline. So there's 2 cycles of my graph of sine of x. So if you notice, when you take a look at sine of x, it's a function. It passes your vertical line test, but notice it does not pass your horizontal line test. So therefore, it's not 1 to 1. So in order for the inverse sine to actually be a function, what we're going to have to do is we're going to have to restrict the domain. So we're going to have to restrict the domain, and we're going to force sine of x to be a 1 to 1 function. So if you take a look at the graph of sine of x from negative pi over 2 to pi over 2, this part of the graph right here. If I just look at this part of the graph, I have now taken the sine function and made it a 1 to 1 function. So when I look at my sine of x with a restricted domain of negative pi over 2 to positive pi over 2. So at negative pi over 2, it's at negative 1, 0, 0, and then 1 pi over 2. That's what the graph of sine of x looks like with the restricted domain going from negative pi over 2 to pi over 2. Notice it's now a 1 to 1 function. So now I can use this graph of y equals sine x to help me take a look at the graph of your inverse sine of x. Remember, like we mentioned with functions and their inverses, you switch the x and the y. So on your point sine of x, you have this ordered pair negative pi over 2, negative 1. So to find the point on the inverse, I would switch the x and the y. So this is going to become negative 1, negative pi over 2. So there is your first point on your inverse function. You have the point 0, 0. So on my inverse, I'm still going to have the ordered pair 0, 0. Then I've got the point pi over 2. I labeled that wrong. That should be pi over 2, and this should be positive 1. Then up here, I have the point pi over 2, 1. So on my graph of my inverse, I'm going to switch the x and the y, so I'll have the point 1 and pi over 2. So then here's the graph of the inverse sine function. So this is the graph of your inverse sine, and this is the function we're going to be talking about today. Remember, just to review, the domain of sine of x, just the parent function, is all real numbers. The range goes from negative 1 to 1. So the domain restriction we place on sine of the x to force it to be 1 to 1 is going to be from negative pi over 2 to positive pi over 2. Remember what happens with functions and their inverses when it involves domain and range. They switch. So since the range of sine of x is negative 1 to 1, that's now going to become the domain of your inverse function. The range is going to be the same as the restricted domain, which will be from negative pi over 2 to positive pi over 2. Just to review also, remember you have this composition theorem back from Algebra 2. This composition is a little different for your inverse trig functions. This composition is only going to cancel out to give you x if. So when I do sine with my inverse sine of x, that's only going to cancel is if this value, if x falls between whatever the domain of the inverse sine is. So if this value falls between negative 1 and 1, which is the domain of the inverse sine. Remember, you can do this composition either direction to give you x. So if I take my inverse sine and I do a composition with sine of x, it's only going to be equal to x if this value falls. So if x falls between whatever the restricted domain of sine of x is going to be, which is your negative pi over 2 to pi over 2. And we'll take a look at that and what we mean by that in a minute. There is another notation you may see for inverse sine. We know inverse is you see the negative 1 exponent. For our inverse trig, we may also see the notation arc sine. And again, this means x equals sine y. Where remember the domain for x falls between negative 1 and 1, and then the range is going to fall from negative pi over 2 to pi over 2. So what that means for the unit circle, because my inverse sine is only going to exist from negative pi over 2 to pi over 2, what that means is when we're looking at our inverse values, we are only looking at values from negative pi over 2 to pi over 2. Quadrants 2 and quadrant 3 are dead for your inverse sine. So remember, inverse sine does not exist in quadrants 2 and quadrant 3 because of the restrictions we placed on sine of x in order to make the function a one-to-one function. So you have a new set of values to memorize. So these are your inverse sine values you have to memorize. So the question you ask yourself when you see this arc sine of negative 1, the question is, what angle has a sine value of negative 1? So now your answers are going to be angles. Remember, this is your y coordinate. Remember, for sine, these are your y coordinates. So what angle has a sine value of negative 1? But remember, the trick is you've got to give me an angle between negative pi over 2 and pi over 2. So the y value, the angle where the y value is negative 1 is down here at negative pi over 2 because remember that as the ordered pair 0, negative 1. So the answer is going to be negative pi over 2. No, you cannot say 3 pi over 2. And the reason is it all goes back to the graph. Why did we have to restrict the domain? We had to force sine to be 1-to-1. It is not 1-to-1 at 3 pi over 2. So you must state these particular values when you're dealing with the inverse sine. So when you look at the inverse sine of negative square root 3 over 2, again, we have to be in quadrant 4 because this is where y is negative. So the angle down here in quadrant 4, where sine is negative square root 3 over 2, is negative pi over 3. At negative pi over 3, the y coordinate, if you look on your unit circle, is negative square root 3 over 2. Still in quadrant 4 because this is negative. So the angle where your sine value is negative square root 2 over 2 is going to have to be at your negative pi over 4. That's where your y coordinate is equal to negative square root of 2 over 2 in quadrant 4. Inverse sine of negative 1/2. Again, this is negative, so you're still in quadrant 4. So the angle where the sine is equal to negative 1/2 is negative pi over 6. So that's in quadrant 4. Inverse sine of 0. Again, that's going to be a quadrantal. Remember, you're looking to see where is your y coordinate equal to 0. On your unit circle, remember, on the positive x-axis, you have the ordered pair 1, 0. So at 0 degrees or 0 radians, that's where your arc sine is equal to 0. So now notice you're moving out of quadrant 4. These values are positive. So remember, everything is positive in quadrant 1. So we're now looking for angles in quadrant 1. The angle that has a sine value of 1/2 in quadrant 1 is pi over 6. Still in quadrant 1 because that's where your arc sine is positive. The angle that has a sine value of square root 2 over 2 is your pi over 4. And then up here is where your arc sine of square root of 3 over 2 is going to be at pi over 3. Because that's the angle where the y-coordinate is square root of 3 over 2 in quadrant 1. Then the arc sine of 1, remember you have this point up here on the positive y-axis, 0, 1. So your y-coordinate's equal to 1 at pi over 2. And again, that's a quadrantal.